In this video, we're going to take a look at some rather unusual properties of Python modules and OTLs, and how to use those properties to our advantage to solve this problem that we're having. Now again, the problem that we're having is that we need to get a path to read and write data to in this read-write OTL. But getting that path is a relatively slow operation, and furthermore, we have to get that path in Python. So what we're looking for is an ideal solution for how to store that path and only get it once. Alright, so let's talk about Python modules. So if we unlock this read-write node and we go to type properties, I'd like to just create a button here. This button will be called set, and we'll create another button, and this button will be called display. So if we hit apply, we'll be removing these buttons later. They're just for use as an example so that we can get a concept across. So the very interesting thing about Python modules and OTLs that is not necessarily the most intuitive thing in the world unless you think about it pretty hard, is that there is really only one Python module for all instances of this OTL. So what this means is that if we define data inside of this OTL, and then we put in another read-write, this read-write can access and change that same data because there really is only one Python module. So let's see this in action. If we say global var equals just an empty string, I guess. We come down here to the very bottom and we just say def set callback, remembering to bring in whonode. Actually, we don't really need to do that for this. We'll just, well, let's do it. We don't need the whonode argument right now, but we will later, so let's just have it there. So let's just say global var. This global keyword in Python means that whatever is following it comes from outside of this function. So essentially we're telling it, I have this global var variable that I've declared somewhere out here, and I want you to go and find it and make sure that I have access to it inside of here. So if we change global var here, or if we try to access its value, it's going to be looking at this one instead of trying to create one that's unique to this function. And then we can just say something like global var equals who.ui.read input, enter a value. And then since that returns int and string, I'm wanting this just a very quick and dirty way, so I'll just immediately look up the first index. Just add a few new lines so you can see. I'm just going to directly look up the first index without checking to see if it's actually there, or if these are cancelled or anything like that. And then we'll create def display callback. Again, we have whonode. Again, we'll have global var so that we can access this outside data. And then we just want to say who.ui.display message global var. Alright, so the idea being that our set button will set the data, and our display button will display the data. So let's see what happens. If we click, so we have this one selected currently. We'll hit set. Of course it doesn't do anything because we need to actually put something in the callback fields here. So let's change that to Python. kwargs node.hta module set callback. And we're passing in kwargs node as the argument. For display, same deal. Python kwargs node.hta module dot display callback kvargs node apply. So now if we minimize this and we say set, we can enter a value. We can say something like fun. Now if we click display, it says fun. If we set it to blorg and we hit display, it says blorg. And then here's the interesting thing. If we go over here to read write, we don't set on this node, we just click display. It also says blorg. If we come back over here to our first node and we say set, and we set it to something completely new like Zorg, come back over here and we hit display, it's updated to Zorg. So you can see that this data is shared across all of these nodes. Now sometimes this is really useful. You can actually use this if, for example, you have two of these nodes and you click the render button and you want it to do something on the set of nodes that's selected on only once. Houdini, when you click this button, Houdini is going to run the callback for the button once for every node that you have selected. But since they all share the same Python module, you can actually determine what's happening there and only run once. Now that's kind of a even more advanced topic than what we're talking about right now, so we won't really get into that. But just be aware that you can take advantage of this fact in creative ways. Unfortunately, what we're doing here is it's really not an advantage to have these shared. We want to store the path in a global variable. But we can't just do it directly because it'll propagate to all the other ones. So when we set the path here, it'll set it here, and when we set the path here, it'll set it here. Now, there is an easy way around this. If we open up our type properties, and we go to scripts, and instead of making global var a string directly, we instead make it a dictionary. Why are we making a dictionary? Well, because we essentially want to have one path for every instance of the node that has calculated a path, which it will as soon as you put it down. Okay, so if we come down here to our set callback, and instead of just saying global var here, we want to look up that dictionary key. So what we can say is who_node equals the read input. So you might be tempted to do who_node.path here, but the problem with that is that if I went to change the name of my node, it would actually have to recompute the path, and it shouldn't have to do that. So if we just give it the who_node instance directly as the key, then path or node name changes don't matter. And now that we're using a dictionary here, we also need to have the display callback look up who_node. So now if we hit apply, we should be able to say set, maybe say 1. If we say display, it says 1. If we come over to read write, if we say display, we get a key error, and that's because we haven't actually set on that node yet. So it's looking up in the dictionary some key that doesn't exist. So if we say set on this one and we say 2, and now we say display, it says 2. If we come back over here to the first one and we say display, it says 1. So you can see that now it's got different values for each one. So it's pretty easy to implement this for our path. If we just come to our path keyword callback, instead of setting user data, all we have to do is do the same thing. We say global var. Remember, this is our dictionary. We can say global var who_node equals current path, and then just still return current path, that's fine. And then when we get the cached path, instead of getting it from here, we could just say, could even get rid of the user data line and just say path data equals who node, or sorry, global var who node. And of course we need to do global var first. So we want this. So no more user data. So now if we hit apply, and if we come over here, now if you remember earlier, we channel referenced this up to here. So let's just go ahead and clear those channel references for now. Just Control-Shift-Click to delete them. Come over here, Control-Shift-Click. Yeah, nothing there. Okay, so now if we set this one to something like blurg, and we come inside, you can see that it says blurg on both of these. And if we come over to here and we set this one to fawn, and we go inside, this one's fawn. So it seems to be working. Now there is a slight weakness to this system, and this is that this data is not persistent. And by that I mean that if I go to Houdini again, and I bring up another Houdini, let's get rid of that. If I open my advanced Python modules zip file that I've been working in, now these are still set on the parameters, but if we go inside here, you can see that this is empty, and it's actually erroring. That's because it's got this key error here. So this is because whenever we run the callback here, it's actually caching it. But that callback doesn't get run when you start up the HIP file, so that's a problem. So all we need to do to fix this is just have our cached path check to see if the path exists in our global var dictionary to begin with. So basically what's going to happen is, if we go inside, this parameter is going to call the getCachedPath function. And then for the first time that the scene is loaded, the getCachedPath function is going to see that the path is not in fact cached. So it'll go through and create the path based on the parameters on the interface. Alright, so let's deal with that. So if we come back out, all we have to do is say path data equal, all we have to do is say path data equals, instead of just looking it up this way, there's actually a function on dictionaries that we can use. So we can say .get whonode. Essentially what .get does is you give it a key in the dictionary that you think might or might not be there, and then if it's there, it returns whatever's inside, and if it's not, it just returns none. So in this case, all we need to do is just check to see if path data exists, or rather if it doesn't exist. So if we say if not path data, so if it's none type, we just need to refresh it. So we say path data equals, or what we could even do is say path keyword, let's see, path data equal path keyword callback whonode. This is better than just calling getPath directly, because what it's going to do is it's going to cache the path when we do that. So now if we hit apply, we can make this 1. We go inside, it's set to 1, that's good. Come back out, set this one to 2. Let's just dive inside and make sure that it is indeed set to 2, which it is. So that's good. Alright, so if I save my HIP file and just go back to my other scene and say reload that HIP file, discard and open. So now I have my 1. It's set to 1 instead of an error. And here's 2, and we go inside. It's set to 2 instead of an error. So that seems to work. Now I should note that This kind of thing is not necessary if you know that your data that you need to get can be accessed very quickly. It's a lot simpler just to have a function here that returns whatever value you need, and then have a Python expression inside here that looks it up. But this is one way to get around it if you have if you have data that you need to get at that takes a long time to compute.